Good day to you, students. I'll be taking you on principle of conservation of linear momentum. Now, what will I be looking at? The principle and conservation of linear momentum. Students should be able to state the principle of conservation of linear momentum and also be able to calculate using the three cases involved in the principle of conservation of linear momentum. Let us look at the principle of conservation of linear momentum. What is the principle of conservation of linear momentum? It states that the total momenta of a system remain constant, same, irrespective of their direction, provided that no external force except collision acts on them. If there is no external force that acted on them, then I believe that the principle of linear conservation of linear momentum is being obeyed. And those conservation of momentum can be stated also as momentum before collision is equal to momentum after collision. And when we say momentum before collision is equal to momentum after collision, therefore no external force is being applied. So from there we want to look at the various types of collision. What are the various types? We have two types of collision. We have elastic collision and inelastic collision. What is elastic collision? Elastic collision is when both energy and momentum are conserved. That means they are the same before and after collision. And we also have inelastic collision. What do we mean? In inelastic collision, momentum is conserved, but energy is not conserved. In such situation, I use local setting that when we say that momentum is conserved, that energy is not is not conserved. That means what we are saying is that one takes over the other. Is not the situation whereby when two collide and both of them share the same energy and the same momentum, but in inelastic, one takes advantage of the other. That is why we say that energy is not conserved in inelastic collision. Now we want to look at the three cases involved in the principle of conservation of linear momentum. Now the first case says that two bodies having these different masses and different velocity are moving on a straight line, and one with a greater velocity collide with the other, and both of them begins to move with the same velocity, and therefore we can generate an equation for that. We say that momentum before collision is equal to momentum after collision. Therefore m1 u1 plus m2 u2 is equal to m1 v1 is plus m2 v2. Therefore we can now say that because both of them are moving and their velocity is common when they collide, that's after collision, then v1 is equal to v2. So we can now make v1 equals to v2 as a common velocity. So we now say that v is equal to m1 u1 plus m2 u2 all over m1 plus m2. That's the first formula for the first case of conservation of linear momentum. I will continue in the next segment. Please, let's hold on for the next segment. Welcome back to the second segment. Yes, we are trying to look at the second case. That suppose an object collide with a stationary object on a straight line, and after collision they stick together and move with a common velocity. Our initial velocity for mass 1 will become 0. So therefore it's going to affect mass 1 when you multiply the 0 with m1. So therefore we now say that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So the m1 u1 will become 0, so we'll be left with m2 u2 is equal to what? m1 v1 plus m2 v2. So but we said that they will have a common velocity after collision, so therefore v1 is equal to v2. So therefore we will now have v is equal to m2 u2 all over m1 plus m2. That's the formula for the second case. Now let's move on to the third case. The third case is very funny and it looks so interesting. It says that two objects are moving in opposite. We have two objects with different masses. They are moving in opposite direction. Maybe one is coming from the east, one is coming from the west. So they are facing each other. So I guess that one is going to have a negative sign because they are moving in opposite direction. So they say that two objects are moving in opposite direction on a straight line. After collision, they stick together and move with a common velocity. And if they move with a common velocity, one will be having a negative sign. And for that, we now says that m1 u1 minus m2 u2. So that means the second one coming from the west maybe is the one carrying the negative sign. But after collision, we now say that m1 v1 plus m2 v2. So and you know that after collision they stick together and move with a common velocity. So v1 and v2 is the same. So we now says that v is equals to m1 u1 minus m2 u2 all over m1 plus m2, and that is the formula derived for the third case. So let us look at an example. A ball of mass is 0.5 kilogram moving at 10 meter per second collide with another ball of equal mass at rest. That means the second ball is at rest while the first ball is moving with a velocity of 10 meter per second. If the two balls move off together after impact, calculate their common velocity. That means they want us to calculate the common velocity they possess. So we know that mass m1 has been given as 0.5, u1 has been given as 10 meter per second, and we know that m2 is also given as 0.5 kilogram, but u2 is what is 0 because the body is at what, at rest. And from our formula we says that v is equal to m1 u1 all over m1 plus m2. So therefore v is equal to 0.5 times 10 all over 0.5 plus 0.5, and 0.5 plus 0.5 is simply 1. And you know that 0.5 times 10 is what, is 5. So therefore 5 divided by 1 is equal to 5. So our common velocity is therefore 5 meter per second. Is 5 meter per second. So let's look at another example. A ball of mass 100 gram traveling with a velocity of 100 meter per second collide with another ball of mass 400 gram moving at 50 meter per second in the same direction. If they stick together, calculate their common velocity. So we follow this we follow the first case, and we say that m1 u1 plus m2 u2 is equals to what, m1 v1 plus m2 v2. And we know that we said that the common velocity is v, and therefore we use the common velocity, which we says that v is equals to m1 u1 plus m2 u2 all over m1 plus m2. So we know that we are giving our mass in gram, so we have to convert to kilogram. That's divided by 1000. That's 100 divided by 1000, we have 0.1 kilogram. Then 400 divided by 1000, we have 0.4 kilogram. So we have to convert that. So from there we now move on and say that v is equals to m1 u1 plus m2 u2 all over m1. So if you put all your parameter in the formula as 0.1 times 100 plus 0.4 times 50 all over 0.1 plus 0.4, so our common velocity will be 60 meter per second. Okay, let's continue the third segment. We want to look at the WAEC past question 2020 January-February exam. It says that two bodies of mass 6 kilogram and 4 kilogram moving in opposite direction with velocity 9 meter per second and 7 meter per second respectively collide and move together. Calculate their common velocity. If you look at this question very well, we'll be using the third case because they are moving in different direction. But if you look at the question, we find out that one has a mass of 6 kilogram and the other a mass of 4 kilogram. So the mass of one is greater than the other. So according to the third case, it says momentum before collision is equal to momentum after collision. So we say that m1 u1 minus m2 u2. So the second mass is carrying a negative sign, is equals to m1 v1 plus m2 v2. And we know that after impact, the v1 is equal to v2, which they have a common velocity v. So we make v the subject of formula according to what we are looking for, the common velocity. So we say that v is equal to m1 u1 minus m2 u2 divided by m1 plus m2. So if we put m1 is given as, the mass is given as 6 kilogram, times the initial velocity of m1, which is 9, so times 9, minus m2, which is mass of the second, which is 4, times 7, the initial velocity of the second, is equals to v open bracket mass of the first one 6 plus 4, and therefore we now say that 54 minus 28 is equals to 10v. So we have to make v the subject of formula, that's the common velocity. So we have 26 is equals to 10v, then v is equals to 26 all over 10. So our common velocity is 2.6 meter. So students, you two are going to make attempt to solve some examples I'm going to give to you now. So let's take our pen and write. An example: an object of mass 4 kilogram is moving towards the east at a velocity of 6 meters per second. It collides and sticks together to a 6 kilogram object moving with a velocity of 5 meters per second in the same direction. Calculate the common velocity. Let me repeat. An object of mass 4 kilogram is moving towards the east at a velocity of 6 meters per second. It collides and sticks to a 6 kilogram object moving with a velocity of 5 meters per second in the same direction. Calculate the common velocity. Then there's another one again I want to give to you. According to the last WAEC also, it said differentiate between elastic and inelastic collision. You know, we have done that. So differentiate between elastic collision and inelastic collision. Then another one also again, define the principle of conservation of linear momentum. Define the principle of conservation of linear momentum. So I believe that with all what we have done today, you should be able to solve any calculations on principle of conservation of linear momentum. Thank you.